Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 15. This is Section 15.2, problem number 15. We want to find the integral of dx over the square root of x times 5 plus the square root of x in parentheses raised to the 7th power. It's kind of an ugly looking problem. And again, I need the substitution method. I have no trick other than the substitution method to get the variable out of the denominator, which I really need to do in order to integrate this. So to start the process off, I have to choose a value for u. Now u could be stuff in the parentheses, stuff in the denominator, stuff under the root, or power of e. They're almost all there except power of e. I do have parentheses, so the u could be 5 plus square root of x. I do have a root, so the u could be x. I do have a denominator, so the u could be the entire denominator, square root of x times the parentheses to the 7th power. There's no e, so at least I get to get rid of 1. I can also get rid of stuff under the root. Because if I go with stuff under the root as my option for u, I have u equals x, which you're never going to use as a substitution. It's just going to give you the same problem back again, just with u's everywhere I see an x. That's not going to work. So it's either the stuff in parentheses, 5 plus the square root of x, or the u is the stuff in the denominator, the entire denominator. Well, one of those two will work, the other one will lead you to a dead end. In the next step, the du is the derivative. So if I choose the stuff in the denominator as my u, to find du, I'm going to need the product rule and the chain rule to find du. It's going to make a mess. It's never going to really match up good. So for that reason, I'm going to try stuff in the parentheses first. So there's a chance I'm making the wrong choice, but since this is much simpler, I'm going to go with that, and I feel very confident that it's going to be the right choice. So my u is 5 plus square root of x. And let me just rewrite that as 5 plus x to the 1/2 power instead of square root of x, because I can't really take the derivative in that format. But when I have a exponent, even though it's a fraction, now I can take the derivative. So my u wound up being the stuff in parentheses, which is 5 plus x to the 1/2. I prefer to write it in that format. Notice I don't take the exponent of the parentheses, just what's inside the parentheses. So next is I'm going to find du. So du, the 5 has no variable with it, so its derivative is 0. It just goes away. Now the x to the 1/2, the exponent of 1/2 comes down times the number in front, which isn't written but understood to be 1. 1/2 times 1 is 1/2. X to the 1 less power. So 1/2 minus 1 is minus 1/2. And then you put on the end dx for derivative with respect to x. So still doesn't look that good. Now, to make it match up, before I start plugging in my u's to replace the x's, let me rewrite this a little bit. I see an x to the negative 1/2. I'm viewing this pretty much, this square root of x in the denominator, as an x to the negative 1/2. So let me start by rewriting this as dx over x to the 1/2 times 5 plus x to the 1/2 to the 7th power. It's the same thing. I've replaced my square roots with exponents of 1/2. And now this x to the 1/2 in the bottom, let me pull it up on the top by making it a negative 1/2 power. So x to the negative 1/2 dx. And then I'm going to have 5 plus x to the 1/2 in parentheses to the 7th. Written in this form, it'll match up with my u and my du pretty nicely. So the trick was to get this square root of x out of the denominator into the numerator as an x to the minus 1/2. Now it's going to match up. That 1/2 is still a little bit off, but that I can deal with. So let me rewrite this. I'm going to have the integral of, the denominator is an easy match. 5 plus x to the 1/2 to the 7th becomes u to the 7th. No problem. Now the top isn't a perfect match. I need to replace x to the minus 1/2 dx Pretty close. X to the minus 1/2 dx. It's times a half in front. I have to cancel the half. Easy enough. I have an equal sign. I can do anything I want as long as I do the same thing on both sides. So on both sides, I'm going to go times 2. So the left side times 2. Right side times 2. That's legal because it's an equals. So on the left, 2 times du is 2 du. Then on the right, 1/2 x to the minus 1/2 dx times 2. The 2 and the 1/2 cancel, leaving me with x to the minus 1/2 dx. So now I need to replace x to the minus 1/2 dx, and I have a perfect match for it. It's equal to 2 du. So now I want to solve the integral of 2 du over u to the 7th. So let me rewrite that. First of all, the 2 can come in front of the integral symbol. Because it has no variable, it's just a 2, I can put it inside the integral or outside the integral. And I like it better out. And instead of du over u to the 7th, let me write that as u to the minus 7 du. So this fairly intimidating looking problem that I started with, this integral with the x's in it, boils down to 2 times the integral of u to the minus 7th du. So I can solve that pretty easily. Notice my negative exponent, I'm not going to need an ln in this case because I'm not going to zero out the denominator. So let's go ahead and do the integral. The 2 that's in front can stay in front times 1 over the exponent of negative 7 plus 1. So I'm not zeroing the denominator. I don't need the ln. I need the ln only when the exponent's minus 1. Minus 7 doesn't need it. U to the minus 7 plus 1. And on the end, plus some constant. So now let's just clean it up a little bit. The 2 in front will stay for one more step. 2 times 1 over negative 7 plus 1 is negative 6. Right? Careful when it's a negative. If it's 7 degrees below 0 and it warms up a degree, now it's 6 below 0. Same type of thing with the exponent. Negative 7 plus 1 is negative 6 plus a constant. And now 2 times 1 over negative 6, I can reduce the 6 and the 2, so I'll have minus 1/3 u to the minus 6 plus a constant. Now that's simplified, but I do have to put the x back in. I can't leave my answer in terms of u. So I have what u is equal to from the beginning, either with the square root notation or the 1/2 exponent notation. I'll have 1/3 u to the minus 6 will be 5 plus square root of x to the minus 6 plus a constant. And if you want, you can pull that whole set of parentheses down into the denominator and make the exponent positive. So the way I have it written now is a perfectly good answer. Or you could have negative 1 over 3 times the same parentheses, 5 plus square root of x to the positive 6 power plus some constant. That's okay too. I would probably just leave it the first way with the negative 6 exponent.